Hello guys, welcome to the mathematics lesson 2 on computers. Okay, so we'll be looking at the lesson 2 on computers. In our previous lesson, which is mathematics lesson 1 on computers, we looked at what the computer is, and also we looked at the basic processes of the computer, and then we also looked at algorithms. Then we looked at the forms in which algorithms can be expressed or written, such as in form of flowcharts and then pseudocodes. And then we looked at the symbols that are used to represent flowcharts. And then we looked at some examples on how to write flowcharts. So in today's lesson, we are going to continue from there, and we will be looking at pseudocodes. All right, because we never looked at them in the previous lesson. We just said that these are the forms in which algorithms can be written. All right, so we looked at the flowchart, and today we are looking at the pseudocodes. So what are pseudocodes? So we are saying that these are English-like statements closer to programming language that indicate steps followed in performing a specific task. Okay, so the key phrase here is that these pseudocodes are English-like statements. So they are like sentences, okay? So they are like sentences which are closer to programming language that indicate steps followed in performing a task. So these English-like statements, they indicate the steps followed in performing a task. So meaning that these ones, you don't need to use flowcharts, but you use English-like statements. And these English-like statements are closer to programming languages. Okay, so you guys that have got a passion maybe to do programming, which is very, very lucrative type of a skill or knowledge, if you have it, there are programming languages such as the Python, Java, C++. So you will be able to in those programming languages, you are going to encounter pseudocodes in more details. But in here, we are just saying these are English-like statements closer to programming language that indicates steps followed in performing a specific task. All right, so let's look at the examples on how to write pseudocodes. So it's very important that I give you some examples on how to write pseudocodes. Yeah, so we have a question like here, which says, write a pseudocode to find the sum of two numbers 2 and 3. Okay, we have been asked to write a pseudocode to find the sum of two numbers 2 and 3. Okay, so meaning that in writing this pseudocode here, we should use English-like statements, okay? And these English-like statements should do what? Indicate steps followed in performing a specific task, okay? So these steps should be like, let's say you are asked to use a calculator to do what? To find the sum of 2 and 3. So what should you do? First of all, you grab a calculator, you switch it on. Then what are you going to do? You start entering notes. So you enter 2, then what else? You enter plus, what else? You enter 3, what else? You enter equals. Those are the steps that you are going to follow in order to find the sum of the two numbers 2 and 3. So even a pseudocode is more similar to that, except that pseudocodes are closer to programming language in some cases. So for this, what we are going to do is to click first to start with solution, then solution or start with start. As always, you need to start with start. Then the next thing is when you start, like, the program switches on, okay? The program that is used to do the calculation, it's like now you switch it on, okay? Then after that, what do? You enter. So enter 2 and 3. You enter 2 and 3. So notice this in the indentation, something like that. So indentation is the way of writing the program. Like start should be on the outside, then enter should be a little bit inside. So start, then enter should be a little bit inside. Then after you do enter there, what happens is the calculator now has to be given what should it do with the 2 and the 3. Then you say sum. So S stands for sum. You say sum, which is now what the computer should do is to say 2 plus 3. Okay, so it's like when you enter 2 plus 3, then you say equals. Now it's like this is the stage. So when you enter 2 comma 3, then the computer will say, oh, what should we do with it? Then you write another step to say, okay, we want AC is equal to 2 plus 3, which will be the sum. Okay, then what else? Then after it does this, it will find the sum here. Then what you do now, it is to finish here. So what you are going to say, it is to display. So you say display S. So now, after the computer does the sum here, it is going to display now the final answer. Of course, the final answer which it should display will be 5. But here we are saying display S. After it displays S, what follows next is to stop. So you say stop here. So you see what it is. So start is on the outside, enter a little bit inside. Then this process, this block which represents the processing of this information here should also enter inside. Then in display should line up with the enter here. Display and enter should line up as it is here. Then stop should line up with the start, like that in the same line. Yeah, so this is just a pseudocode of the question which says find the sum of two numbers 2 and 3. So this one, if it were to be shown on a flowchart, it would look like this. Start, then enter 2 3, then process, which is S is equal to 2 plus 3, then it display there, then you stop. This is how it would look. So this is a pseudocode for this particular question or problem, and this one is a flowchart for this corresponding pseudocode. Yeah, so let's look at another example. So example 2 says write a pseudocode to calculate the value of R using the formula R is equal to small letter r is equal to capital R cos x, where x must be positive or where x is positive. Yeah, right. So now this is the question. Write a pseudocode to calculate the value of small letter r using the formula small letter r is equal to capital letter R cos x, where x is positive. Okay, let me change. Yeah, where x is positive. Now, I must mention that when you hear like where x is positive, it means they've given you a condition. So whenever there's a condition in a question, then you must use a decision box. That decision box which we had to show in on a flowchart previously in the previous lesson. We had a decision box in a flowchart, which is a rhombus or diamond. So where there's a condition like where x is positive, meaning that x shouldn't be negative. That is a condition. So when they say x is positive, meaning x shouldn't be negative. So there are two conditions there. So in writing this one, solution, we are going to always have a start. Okay, we'll have a start. Then what are we going to do? So we have been told x is positive, meaning x is the input value that we'll be using. So R, they are silent about it, capital R here. So we'll say, okay, enter x. Enter x. X is what we'll be manipulating here to find the R. So you say enter x. Then after you enter x, then you say because of this condition here where x is positive, so you use this condition if x is less than 0, then what are you going to do? Then you are going to say print this one here. So it should be able to print x must be positive. So say if x is less than 0, then print x must be positive. Okay, print x must be positive. Now, why should you say print x must be positive? Because if you are intelligent, or maybe intelligent enough, if they are saying x is less than 0, if x is less than 0, meaning x is a number which is below 0. So those numbers which are below 0 are negative. Okay? So meaning that the calculation won't work of finding what? R, because if x is going to be less than 0, then it will be negative. Then the calculation to find R won't be done. Now, why even putting this one here? You are putting here because in an event where a person writes a negative, because it's either they can write x having a positive value, or they can write x having a negative value. But in this case, this will only work when x is has a positive value. So this, you are putting this condition here so that it prevents this program from going ahead when someone enters a negative value. So you are preventing it to go ahead. That's why you are saying if x is less than 0, then print x must be positive. It's like it should tell that person to say, no, 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 no. You have entered a negative value of x. It's not negative value we are looking for. We are looking for a positive value. Okay, so that's why you say if x is less than 0, print x must be positive. Okay, now if this is not the case, you say else, meaning if x is less than 0, then print x must be positive. Now, else you're saying, okay, in an event now it is not agreeing with this. In an event, it is not true that x, you haven't entered the x is less than 0. Then you say else, then after else, then what do you do? It should now find the value using this formula. So you say else r should be equal to, small letter r should be equal to capital R, then times cos x. So you are telling it to say, okay, or else if the person has not entered x negative or less than 0, then go ahead to do the calculation of the value of r. That's why we are saying, or else r is equal to, small letter r is equal to capital R times cos x. Okay, then from there, after it does this one, now you are going to end if. So you see the aligning, this one start, then enter inside the bit, if inside the bit, print x must be 0 inside the bit, then else should line up with if. Then this one here should also line up with the print here. Then after that, you say end if, meaning you are terminating this condition here. Then you say, you come here, enter, then you say display R. So it has finished here, and if, then you say display R. Okay, meaning it would now display the calculated value here, will be displayed here. Okay, so this should line up with the enter. Then after that, you say stop. That's how it should be. So this one is a pseudocode for this question here. So this pseudocode can also correspond to this flowchart here. So if you were to change this into a flowchart, then it would look like this. Start, this one, start here, enter, x, this one here. Then if x is less than 0, now on a flowchart you say is x less than 0, you put a question mark. Now, if it is yes, okay, if a person enters x is less than 0, and that is the case, then you should say print error. Okay, x must be positive, okay, which I did not change. Actually, here it should have been, okay, print x must be positive. Remove this error because we didn't include it here. Then it should be here like no. If it is no here, it is not the case that x is less than 0, then it should go ahead to do this, because meaning the right value has been put in, which is positive. Then it should now calculate the value of r of x of r, I mean, after entering a correct x here. So when you enter x here, it should be checked. Is x here negative? If it is yes, print x must be positive. Okay. But if it is checked and it is found that x is positive, then it should go ahead and write and process this one using this formula. R is equal to capital R times cos x. Then after it does that, it calculates, then it should display it here. Then after that, it should stop. So meaning, you have seen this has been connected here. It means that this will be, this is connected to stop here. Meaning that the program will not go ahead. If a person entered the value which is less than 0, the program will go straight to stop. It will not go ahead. It will just say print error, print x must be positive, and then it stops. It will not go ahead. That's what it will do. But if you enter x and it is verified that x here is not less than 0, then it will go ahead and calculate the value of r, and then it goes ahead and it displays the value of r, and then it stops. Okay, so this is what it means. This one and this one are the same. This one is a flowchart, this one is a pseudocode. Then let's go to another part of the lesson. So we are now going to look at converting flowchart to pseudocode. Okay, converting flowchart to pseudocode. So we'll look at it. When you are given a flowchart, how can you convert it to pseudocode? So you are saying example. So write a pseudocode corresponding to the flowchart program below. So they are telling us to write a pseudocode corresponding to the flowchart program below. So this is a flowchart. Then they're asking us to write a pseudocode. Okay. Then what we are going to do here, we are going to answer this one. So we'll write a pseudocode which corresponds to this. So what we will do, this is answer here. So solution. So we'll write it from here. So start will be just start as it is in pseudocode. This is flowchart pseudocode. Then enter, you write it as it is, but it should be inside here. So you say enter A. Then here, they will check for A. Here they're saying is A, when A is entered here, to be checked, is A less than 0. Okay. If yes, it goes like that. But here it's like enter A. So now where it's saying is A less than 0, here it should be like if you check. So start, enter A. Now it will check. If A, which is entered here, is less than 0, then what would it will say? It will say like then print error. So you say then print error, meaning if it is yes, it goes to this one here. Okay. So if A is less than 0, then it will proceed this direction where there is yes. Then this direction where there is yes, you say then print error, then print, then you come, you say then print, then you write error must A must be positive. Okay, I've seen, I've just added then print, then I've taken this one here, A must be positive. Okay, so meaning the computer will stop the program and tell a person to say, oh, it will print on the screen error, A must be positive, meaning it is guiding this person to enter the value of A to be positive. Then after that, but if this is not the case, Then if this is not true, it will check this number, discovers that this number is not less than 0. Then it will proceed to this direction here. So here, go in this direction, you say else, then you say else, it will proceed. If it checks and discover that this number is actually positive, then it will proceed to calculate h here. So it will say, okay, enter h. So it goes enter h. So this else is in a straight line with this here. Then this enter h is a little bit inside the else. So you say enter h, you come here. Then you discover here that there's also a condition here. So which is saying is h less than 0. So meaning it is checking this h which has been entered here is being checked if it is less than 0. So here now you say, okay, you do it the same way here. Straight with this, you say if h is less than 0, then if this one it is yes, then you do here, you say print error h must be positive. So you say this, it should be line up here. Say then print error h must be positive here. Now if it is checked that this h here is actually not less than 0, meaning this process should continue here, where you're saying no, meaning this h which was entered here, is it less than 0? If you say no, then you proceed to here. So you say else, as you proceed here, you say else, then you use this one here. You say v is equal to a times h. So this represents times here. In computer programming, we don't use that times like that. We use a star like that. Okay. Then after that, what will happen after it has done that? Then what should be done now? Since you used if and if here, then you say end if. So this my if here will be ended because the job will be achieved at finding here. So at finding v here, so the job is achieved. Then after that, it will end if. Then you come to display. So this display should line up with this enter here. So you say display v here. Then you say stop. Stop should line up with start there like that. Stop. Okay. Then that will be the end of this pseudocode. So this will be the pseudocode for this flowchart. Yeah. So another way of writing it is this one here. So you can say start as it is, then input a there where we can say enter a. Then you say if a is less than 0, this a here was less than 0, then print a must be positive here, like that. Then after that, you can command it to stop. Okay, this program can be commanded to stop. Then you say end if, can end here. This is another way of writing it. So end here. So meaning this has been ended. Then after this has been ended, then you can go again to input h. Okay, like here, input h. Then again it will be checked. Is h less than 0? Where you say if h is less than 0, then print, it will go to this print h must be positive. Then stop. Then that will be stopped. Then you come end if. This end if for this if and if here. Then you say set v is equal to a times h. Then print v, then end. So this is also another way of showing this. Yeah. So we have come to the end of this lesson. So we have a task which says write a pseudocode corresponding to the flowchart program below. So this is a different question, but similar to the one we have just looked at, so that you can practice how to write pseudocode. So you answer this one and then send for marking in the group. All right. So for those interested in online lessons for GCE 2024 grade 12, the number is on the screen, 0977 92 41 75. So mathematics is actually 60 kwacha. I charge 60 kwacha for you to join my online lessons for mathematics. Okay, thank you for watching. As for now, bye and see you in the next lesson.